want the quiz Monday? Oh, really?
Because there's
Well, if we
quiz tomorrow, there's 3 lessons left to be Monday, Tuesday, Wednesday.
No school on Friday.
There's no school Friday.
What?
There's no school Friday. So like we have to be here 4 extra hours on Monday and then 4 extra hours on Wednesday, so that's like a full day. So that's like our 40 hours. So we don't work on Friday, does it? Okay, so I just want to give you the quiz for the. It's probably best when we make sure we get this test before spring break, probably more so than a quiz, even though I'd like to give you some more quizzes. How about a Saturday quiz? All right, well, just keep pressing on, get your test on Thursday next week. Cool with everybody?
Yeah. Wait, so if we had a study session Wednesday, when would we do it?
Good one.
Well, like, if they win Monday, there's a game Wednesday.
I think it's during the day.
It's like at 3 something.
So like in class and then after the game.
Probably after
Sure,
church.
after we go.
Cool. Good. We're figuring all this stuff out. I like it. All right. Bases. So here are your strong bases that you're going to need to know. I think it's easier to know these strong bases than it is to know the strong acids because it's all of the group 1 elements with hydroxide. So LiOH, NaOH, KOH, RbOH, and so forth. Okay, and then it's 3 of the group 2 elements, and it's middle 3 here, or kind of middle 3. I don't know, yeah. So it's these 3 you got to remember. So any of these guys with OH, and then calcium, strontium, and barium. Okay.
Why does it just get NaOH and RbOH?
I didn't want to write them all out. It says all group 1,
Yeah.
so. Now, obviously, those group 2 ones are going to be a little bit more impactful. Why? Why would the group 2 ones have more of an effect? Yes. You have 2 hydroxides. And if they completely dissociate, there's no stepwise dissociation of these. And if that completely dissociates, it's going to get rid of both. Okay. All right. So this guy is a what? Strong base. Okay. Do we do any ice tables for strong things? No, we know they completely dissociate, so that's nice. It wants the pH. So what is the concentration of my H+?
5
No.
0.
No. I knew you couldn't. You can't answer that question without doing math work. I was just trying to see if you would just say this, because that's the concentration of OH. Does that make sense? Okay. So when you're dealing with bases, the process is the same except for a couple things. We're going to get into what Kb is later. Okay. But also, when you're dealing with bases, you're usually solving for hydroxide, and then you have to convert that to hydrogen ions to get pH. Does that make sense? So, because this is a strong base, I know that my hydroxide concentration is this because of the 1-to-1 ratio and the fact that it completely dissociates. So then I would use those equations that we had earlier to be able to find the H+ concentration. When you do that, you should get 10 to the negative 14. finish it. What? Square root?
I was thinking like the x squared.
To get pH, you mean?
Yeah.
Oh, negative 1.
10.
I don't ask enough questions. I don't make you think in class.
Normally Rylan answers.
Yeah, that's true.
Rylan usually says something that I have no idea. And you're just like, yes, that's it. And I'm like, what?
Well,
That's pointless
his
questions.
problem is he answers it in the most bizarre way. And I know enough information that's like, yeah, that's kind of right. But I'm not wanting to like hurt his feelings so much. Just be like, yeah, that's way wrong. But it's like not the best way of describing it, if that makes sense. And this is on the video camera. So hi, Rylan. Shoot, I should.
He's gonna watch this. 3 stars.
Darn it. I love you, Rylan.
So Rylan said it'd be the part where he goes, this is the part where Kramer puts his foot in his mouth.
Yeah, this is the part where Bear puts his foot in his mouth. All right. Okay, what did you guys get for pH?
12.6. Yeah, 12.6.
Approximately 12.7. All right, so again, are you seeing the strong stuff? It should be the easy stuff if you remember a couple things. That they completely associate, okay? And if it's a strong base, that you have to flip it to hydrogen ions when you do the pH. Got it? All right, weak bases. All right, so then here's just kind of your generic equation for a base. Base is going to accept the hydrogen from your water, producing that and giving you hydroxide left over. Okay? A weak base is a base that reacts with water to produce hydroxide ions to only in a slight extent because it's a weak base and does not dissociate or react that much. Something I do want you to write down. Ka times Kb equals 1 times 10 to the negative 14. What I could do is I could write the equilibrium expressions out and of like a forward reaction, but the reverse reaction would be basic. And you would see that everything would cancel out except for hydroxide in your hydrogen ions, and that's why Ka times Kb gives you 1 times 10 to the negative 14. Okay, here's one thing that I do want to note that you might want to take at least a mental note of. A lot of times in your homework or potentially on your test, I might give you the Ka of the conjugate of the base you're dealing with. Or in your book, it might give you, give you a base concentration of this, but then not give you the Kb. What you would have to do then is go into your book and find the Ka of its conjugate. In the book, you could look up and find the Ka value of that. From that information, you could use this equation to find the Kb of this. Does that make sense? But they have to be conjugates. So it's possible that on your homework or on your test, I might not just flat out give you the Kb. All right, does that make sense? You might do a little searching. And then I could write the Kb expression, but it's just like doing a Ka expression. Make sense, everyone? All right. Let's do this one then.
So,
Yep.
couldn't NH3 be an acid? How do you know that it's a base?
Yeah, that was a tricky one because it has a lot of hydrogen, right? You might be able to think that it would give off a hydrogen, right? Is that what you're saying?
Yeah.
Yeah, that's one you're just gonna have to know. I can't think of anything that would suggest why it would be an acid or not. I guess for me, it's just I've always known it. So All right. That's probably because I know ammonia very well, the ammonia ion, NH4 plus, and in order to get NH4 plus, it had to have gained the hydrogen, right? So, all right, let's do this here. Same as always, identify major species. I'll just write the equation here. NH3 will react with water. It's going to give you something different though, won't it? What will it give you here? And OH minus. Hydrogen from water goes to here, leaving you with OH minus. So that's just your equation. We still have to do normally we would do our major species, correct? Where you would identify this as a weak base, that's weak as well, and so what you got is these are your major species. Which is going to be the dominant giver of your hydroxide? And the answer would be, because of this here being way bigger than 1 times 10 to the negative 14. Now we're talking base, so technically this is still 1 times 10 to the negative 14, but you would still use that to determine, because this is an amphoteric substance, so you'd still use that to determine if it's a stronger base or not. Okay? All right, then we could write our equilibrium expression. Products over reactants. I suppose at this point, you probably don't need to always be writing that out, even if you probably could do a question. All right, I'm sure we give myself some more space. I'm going to erase this. Okay. Now what? Okay, they gave us an initial wholly concentrated. All right. Now I'm going to go ahead and say this. Would this be a logical conclusion to come up with? We know this is weak. Since this is heavily concentrated, what is going to be true about the 5% or dissociation of this? It's going to be really small, right? Do we say the more concentrated it gets, the less it dissociates, the more dilute it gets, the more it dissociates? Okay? Just little things as you process this that kind of are red flags if you do the work and something just seems like an outlier. Use some of this information. So we got 15 molar. 0 and 0. Okay. We're going to assume shipped right because I don't have any products. Plug in. Squared over 15. Does everybody know what I did there is simplification? I didn't show every little step. I removed the x.
So why'd you get rid of the H2O?
Because I ran out of space, threw it in ice table, so I just got rid of it. It's not going to be in the equilibrium expression anyway, so.
Well,
So you don't put the other, so you just put whichever one is on.
Yeah.
oh, yes.
Yeah. So I showed the whole equation, but then I removed it just so I had more room to do the ice table because it's not even in the ice table.
Okay.
So that's why I got rid of it, yeah. Good question. Anybody got an X yet? 5.2? No. I don't think so. 1.6 times 10 to the negative second?
That's not
Really?
Did you do parentheses?
Now,
I thought you were
this is where you're going to need to put up your red flag. Well, I probably should figure out the 5% test first. But it's going to pass. I can almost 100% guarantee it based on our previous stuff. When you do the 5% test, what we get? Yeah, that doesn't associate much. 0.11%. But since I had 15 molar of it, I still did a decent amount of X here. Now, the thing you need to hold up, wait a minute, it's a little bit different, is this X is what? OH. Alright, if I were to take this X and plug it back in here, it's the OH concentration. It wants pH. So what are you going to have to do additionally then to get the pH when you're doing this? Well, you're going to have, you can do it two ways. You can take the negative log of this and that will give you POH, and then subtract that from 14. Or you can convert this to H plus concentration using the KW equation, and then take a negative log of that. Whatever you prefer. So if you took negative log of, oops. Sorry you guys are sick. I hate being sick. Not all of you are sick, but a couple of you have been sick.
Can you just find the pH? Or I mean
There's two ways to do it.
yeah, because you can find the H. And
I could take this, convert to H plus concentration, take negative log of that. Or I could take the negative log, get pH, subtract it from 14. Which, on mine, work here, looks like I did the other way. But. So POH would be 1.8, 14 minus that. 12.2. And you should get that same answer converting to H plus and then negative log of that. Good? Questions, anyone? This is a newer schedule. Ooh, 7 minutes. You don't have much time for a couple days. When you actually do get more time, it's like, wow. Plenty of time. Okay. This one here. We'll just walk through this one really quickly. Show you again. I kind of showed you the quick method, but I'm just hesitant to show you the quick method because the reason why I'm hesitant to do that is when you start using the quick method, you start asking some of the important questions that you need to start asking. Does that make sense? When you go through it so quick, you tend to not analyze the problem as much, and so you might miss the fact that I gave you Ka instead of Kb. Or you might miss the fact that you have to take the negative log of, or you got to find your pH when you're given OH when you solve for it. Okay, so do not, I do that so much. Do not go so fast when I show you the quick method. Here's how I would process this. Kb is going to be higher than water, right? Major species, dominant giver of the OH minus concentration. Make sense? You guys probably don't know what that is. However, it's only going to give off one hydroxide. Now, normally I'd show it, but if I showed it, well, I'll just, or it doesn't give off one hydroxide, but it only accepts one. It only accepts one hydrogen. Okay? So now that's going to only accept one hydrogen, so everything's going to be a 1-to-1 ratio. If everything's a 1-to-1 ratio, X squared, because 1-to-1 ratio. Initial concentration minus X, I'm going to get rid of the X. Following? Square root of, well, this time's 1, so really just this. I'll put it in there just because. That'll give you your x. And you got to remember, this is where I'm saying if you just go so quickly and you stop asking yourself the questions you would ask if you were going through the long method, you would need to remember that this is a base, so it's going to give off hydroxide. So your X is hydroxide. And then you guys do, well, I still need to do the 5% test. Let's see that. I know most of the time we're like, yeah, it's almost always the 5%, but don't always assume it, because I guarantee you there will be at least one on your test where it won't be the 5%.
How do you know this one is a base? Will it like give us the equation on the test? And we'll know if it's OH?
This is probably the best way to know it's a base. Unless it gave you some information like it said, here's your base, and then they give you the conjugate acid and give you the Ka of that conjugate acid and ask you to solve for something. Then that's where you might have to do a little thinking. But if they give you Kb, assume it's a base. All right, 5% test. You guys get 2.1%, or waiting for me to just write that out? What? Oh, wow. Yeah. Woo-hoo. See, I'm even making a mistake going fast. You guys should just do the whole thing. How about that? Why don't you just do the whole thing from now on? What? You already did.
I already solved it.
What do you got for pH? 12.32. Everybody? Okay. Perfect. We're done. All right. Hope you're feeling all right there, Rylan.
You're not bad at that.
No, I'm not.